In this final lecture video, let's take a look at some of the ways that emerging technologies are shaping transportation and consider some of the pros and cons of these influences. We often tend to really celebrate, maybe even put on a pedestal, new technologies, and certainly they have and will continue to offer a lot of advantages in terms of our lifestyles, but they may also have a lot of unforeseen consequences. Just imagine, for example, someone standing at the turn of the 20th century and trying to look ahead at what the influence of the automobile might be on things like transportation and land use, and even aspects of social structure over the next century. They probably never would have forecasted the repercussions. So, while I'm sure that we'll be surprised in all sorts of ways by the impacts of technologies like electrification and autonomy, we can leverage some of what we know about relationships between things like demand and travel costs to think about what some of these influences might be. So, there are a number of different key areas in which we can expect new technologies to have really substantial effects on transportation. And importantly, it's kind of difficult to tell the directionality of these influences. For example, we could imagine new technologies reducing travel demand if people don't have to travel in order to accomplish things like work, for example. But there's also really good reasons to project pretty substantial increases in travel demand, especially related to, for example, travel time costs. If those costs go down, then there might be substantially more demand for transportation. So one reason that travel time costs might go down has to do with something like autonomous vehicles, where the vehicleist might do the driving for you, which means that you don't have to commit the time to the driving. You could do something else. On the other hand, if there's substantial increases in demand, that might feed back into higher travel time costs if there's substantially more congestion. Energy use has been another really major area of innovation in transportation systems, and there's good reason to believe that technologies will drive energy efficiencies at the level of both individual users and also systematic efficiencies. On the other hand, total energy could actually go up if there is greater demand for transportation, perhaps even spurred by the greater efficiency. So remember the rebound effect from Module 8. If people save more, they might actually end up using more. System efficiency might increase in transportation systems if they're better coordinated, so think, for example, connected vehicles, but also be reduced by technologies that allow for individual users to demand more from transportation systems for lower personal cost. So, for example, if you can send your vehicle around without you even in it, a zero occupancy vehicle, then that effectively reduces system efficiency. Safety has traditionally been a real focus for transportation innovation, and there's still a lot of opportunity to improve safety, both through smarter systems, more engineered systems. On the other hand, more transportation has always meant more crashes overall, and we're entering an era in which it's really increasingly difficult to tell who's responsible for those crashes. So that brings us to this last area of effect, and the only one where I think we're pretty certain about the direction that it's going. So undoubtedly, new technologies will introduce new inequities in transportation and other urban systems, and will spark some really complicated moral and ethical and legal dilemmas about how to address those inequities and who's responsible for them. So let's now dive a little bit into the particulars of how these different effects might work out. So one area that folks in the transportation field are really interested in how technology will affect is demand. And there's always been projections that information technologies like the internet and even telecommunications like the phone would really reduce transportation demand. That said, it hasn't always worked out as we presumed. In 2015, so this is going back a few years, certainly pre-COVID, only about 3%, just less than 3% of U.S. workers were able to telecommute. And even in the places with the highest levels of telecommuting, Austin, Texas, just under 7%. And so for whatever reason, telecommuting is not tending to replace transportation. In some cases, we even end up finding that having interactions with people by telephone and internet spurs additional transportation because it spurs additional business connections and personal connections that then become reasons for more personal or business travel. That said, during the few months around the COVID pandemic, about a third of Americans have worked from home. So that's a really dramatic increase, relative to these sort of standard levels of telecommuting. It also reinforces that, perhaps there's about 2/3 of the American workforce that can't work from home. And so, even at the absolute maximum, spurred by a pandemic, there's still a really sizable part of travel demand that probably cannot be practically reduced. Another really important influence on travel demand related to technology has to do with, how travel time costs might be affected by technology innovation. It's presumed that one of the major factors that controls demand in travel has to do with how much time you're willing to devote to it. So remember, way back to the first module when we were talking about travel time budgets, if you have to dedicate a pretty sizable chunk of your daily schedule to travel, then you might be really incentivized to minimize that, especially if you're not able to do other things while you're traveling. You're not able to essentially multitask. There are definitely some existing modes that allow for multitasking while traveling. So, for example, if you take a commuter train, then you could theoretically be productive while you're traveling. You could do work on a laptop, you could read. And so that's not really wasted time, or it's not time that's exclusively devoted to traveling. However, the vast majority of commuters are currently commuting by car, and if you're driving, particularly a single occupancy vehicle, you have to be devoted to driving during that time. Some people certainly do talk on the phone, although it's not a particularly good idea from a safety perspective. So what that means is that autonomous vehicles really might reduce travel time costs. So in this promotional photo from Volvo, for example, you see someone who might be commuting, and simultaneously being able to, read, get some work done, eat their breakfast. It means that you might be able to devote substantially more time to traveling because you're not devoting that time in an exclusive way. And what that could do is dramatically increase the amount of time people are willing to travel because they can get so many other things done alongside it. There have been some really interesting studies done. An example out of Joan Walker's lab at Berkeley that gave people chauffeurs as a way of simulating what it might be for them to have an autonomous vehicle. And lo and behold, they do travel substantially more than they did previously when they had to drive their own car. So it will be really interesting to see how this plays out as autonomous vehicles become more common within the next several decades. Another area of technological innovation that has already been really influential on transportation systems has to do with energy efficiency. Going from, for example, the Model T, which was the first, mass market car, getting somewhere in the range of 20 to 25 miles per gallon. And certainly a lot of today's cars actually do worse than that, because they're substantially heavier and have substantially more powerful engines. That said, we certainly have developed technologies, particularly electric technologies, that are just substantially more energy efficient, even with fairly high performance. The Tesla vehicles are a great example. That said, today we use, many orders of magnitude more, power toward transportation than, we did in the era of the Model T, simply because so many more people are transporting and are doing that, so much longer distances and more frequently. And so it'll be interesting to see how we balance improvements in energy efficiency on a marginal level, how much you as an individual need to consume to travel a set distance versus the consumption of energy on an aggregate level. And a lot of forecasts, particularly if we have situations where people are just traveling substantially more, there's more demand for travel because the time costs of travel have gone down. even if we have much more efficient modes of travel, we still could see really dramatic increases in the overall amount of energy that's consumed in transportation. One option that new technologies bring to the table in terms of increasing system efficiency has to do with coordination between vehicles. And an example of that has to do with what we call communications-based train control or positive train control, where by building systems that allow trains to, communicate with one another and be, controlled in their spacing and their speeds relative to one another more efficiently, you can put substantially more trains on the same track in the same amount of time. So, for example, with the existing train control technology that's on BART, which relies heavily on the drivers of the BART trains as human operators, with a fair amount of spacing between the trains to essentially account for human error, we can get about 24 Transbay trains an hour through that existing infrastructure of the Transbay tube. And with a new positive train control system that is being installed along with some major upgrades and things like tracks and some new cars in the BART system, we're going to increase that to 30 trains per hour per direction through that same tube infrastructure. So there are some real potentials to, keep even some of the same base infrastructure, not having to build, a whole new set of tracks or a whole new tube, and really substantially increase the operating efficiency of that infrastructure. The same sort of approach could theoretically be applied to automobiles. So there's right now a lot of talk about how to, make more connected vehicles that might be able to essentially speak with one another in a fairly dynamic way, and therefore remove some of the inefficiencies associated with things like intersection control, with traffic lights, removing some of the delay, and also, allowing cars to, for example, travel more closely together on something like a highway. Right now, for example, if you're driving on the highway, then you should keep a fairly substantial following distance from the car that's in front of you, so that if they slow down, you have time to react and slow down yourself. And then all of those following distances and the ripple effects of people sort of reacting with slight delays to what's going on in front of them is actually in itself a major cause of congestion. And so you can imagine that if vehicles were more connected to one another, they might be able to follow at substantially shorter distances, essentially increasing the efficiency of the space use on something like a freeway, and also move more synchronously with one another so that, if a car slows down, a mile or two up ahead, then all the vehicles that are, moving toward that might be able to respond fairly dynamically and quickly and in coordination with one another, as opposed to having these really dramatic ripples and delays in how different drivers are reacting to that situation. So there's a lot of potential for really substantially improved system efficiency related to technologies, if we can get those systems standardized enough, and also if we can develop safety mechanisms that have good track records and allow us to trust these systems and maybe even, regain control as drivers in situations where there's a failure of the technology. So while there's a fair amount of potential for technology to positively influence system efficiency, there's also some really substantial opportunity for technologies to decrease system efficiency in the aggregate. So something that might seem beneficial for an individual, such as an autonomous vehicle that can drive itself, which would essentially give me a lot more flexibility to say, my vehicle needs to pick me up here at a certain time, and then it needs to drive back home, so it's not paying for parking in, for example, downtown San Francisco. This might have really substantial negative impacts on system efficiency in the aggregate. We already have a substantial efficiency problem related to single occupancy vehicles, where we're essentially expending far more resources than we need to move individual drivers in their individual cars, with all of the roadway resources and energy resources that those demand. Imagine if a really substantial part of travel demand was now zero occupancy vehicles, because people have the ability to essentially send their vehicles autonomously wherever they want to. this would represent a really dramatic decrease in system efficiency. So this is something that we will have to address probably on a policy level, because it's forecasted that the ability on a technological basis for something like zero occupancy autonomous vehicles, will be coming, I don't think right around the corner. I don't think we're probably going to see this within the next 5, maybe even 10 or 20 years, but within the next several decades, probably we'll be getting to this point, and then we'll have to figure out, how do we regulate this? How do we maybe even charge enough for it so that it sort of holds that excess demand in check. Another really important aspect of adoption of things like autonomous vehicles, and maybe the ability to be personally benefited by having zero occupancy vehicle movement, is that this is almost inevitably going to be a very inequitable distribution of resources. There are going to be people who can afford to have, autonomous vehicles, but there are going to be a lot of people who can't afford that and are going to be negatively influenced by really increased travel demand and the congestion that might come along with that. And so it'll be really important for policymakers to consider those inequities and try to use policy levers, probably through progressive pricing structures that charge people who do have enough resources to have an autonomous vehicle enough so that they don't just have huge inflation of demand and therefore infringe on access to the transportation system for those who don't have the resources to have something like an autonomous vehicle. Another really important area for technological development has to do with safety. Certainly, there have been a lot of improvements in terms of safety related to the designs of automobiles and highways, for example, things like seatbelts and airbags and crumple zones, engineering in cars that has substantially improved the outcomes, in particular for the people inside the cars when cars are involved with crashes. That said, increasing levels of automobility, so more driving that's happening, and also higher speed driving, has had, as we've discussed in previous modules, really substantial implications for the safety of people like bicyclists and pedestrians. There's a lot of potential for new technologies that are related to autonomous driving or are sort of assisting drivers to improve the way that cars are interacting with vulnerable road users like bicyclists and pedestrians, to do a better job of detecting where people are on the roadway, yielding to them, and also just driving in consistently safer ways. A lot of crashes have to do with reckless driving too fast, driving with impairments. And so technologies that connect vehicles and connect between vehicles and roadways may have the potential to, create driving environments that are more standardized and where, cars essentially follow the rules because they're programmed to do so. That said, one of the real challenges to viable autonomous driving technologies has been how those technologies interact with real human users and the unpredictability of human users, the complexity of travel paths and speeds and behaviors associated with users such as pedestrians. I think it's actually quite scary, but at the same time quite probable to imagine a situation where autonomous technology takes off, but it does a poor job of interacting with other road users. And so the solution that we pose is to just separate them from one another and say, we just won't have pedestrians on city streets because it's too dangerous for them to interact with new driving technologies. That's essentially what happened, in the 20th century when cars, dominated city streets and pedestrians, got pushed onto sidewalks. And in many cases, cities were just designed, without pedestrians in mind because it was considered an inappropriate use of that space. So I think we can be cautiously optimistic about how new technologies, particularly automotive technologies, might improve safety, but we need to make sure that we don't end up just using the removal of vulnerable users from these spaces as a mechanism for improving safety. These technologies have to be challenged to do a good job of actually interacting with human users in these spaces in a safe way. Related to safety, there will undoubtedly be some real dilemmas that we face over the next few decades about how to deal with who's responsible for the increasing role of technology in transportation. Is it the people who created that technology, or the end users of that technology? And furthermore, how do we, design that technology in such a way that it acts in a moral and ethical and legally responsible way? This is already being tested with, issues related to crashes of some autonomous and semi-autonomous vehicles. So, for example, this crash of a Tesla that was using the autopilot functionality, which is a semi-autonomous technology. And this question of, is this Tesla's fault? Is this the driver's fault who, ostensibly was paying attention, but, wasn't able to regain control fast enough to, avoid this crash? There are also some really substantial moral dilemmas in how one might program or design a system, assuming that it does have the technical capacity to function as expected. Should the autonomous vehicle be programmed to protect its driver, or should it be programmed to protect other people at the expense of the driver? Ultimately, how is that system going to be designed? And honestly, I'm pretty pessimistic, short of some sort of government regulation that intervenes on this process, that designers of autonomous vehicles would do anything but protect the driver or the owner of the autonomous vehicle, because they're the ones that are making the decision to buy it. And would you buy a car that was essentially programmed to sacrifice you to somebody else? It might feel like the virtuous thing to do, but it's probably not the market outcome that is likely. So there's a lot to figure out, both on a technical level and also, on a moral level. How do we need to regulate these things? And then how do we set up a legal framework that puts liability on the correct person here? We still haven't really figured out the extent to which situations like this are Tesla's liability or the driver's liability, or maybe even someone else's liability, depending on their influence over the crash circumstances. So in sum, on this question of whether technology in transportation is a solution or a disaster, unfortunately, the answer is both. There is really no easy answer here. We can predict that the transition to new technologies in transportation, particularly things like electrification and autonomy, they're going to be a bumpy ride. They're not going to happen seamlessly. There are going to be really substantial legal and also cultural hurdles, and that those hurdles will probably be higher than the technological ones. So certainly we have a long way to go in terms of developing, autonomy in vehicles in an effective way on a technical level. But I actually think that the bigger hurdle, and the thing that might actually push something like the autonomous vehicle revolution, maybe even decades and decades into the future, has to do with the legality of operating these things, and who's going to assume the liability for those. And then finally, unfortunately, as essentially throughout all of history, more privileged users are probably going to benefit disproportionately from these technological advancements. And so a really important role for government regulation, and also, for planners who are figuring out how these systems should be implemented at city or regional scales, is how to try to distribute those benefits more equitably across people who, can't necessarily afford the most current technological innovation.